We've, I think, done about 5 or maybe even 6 videos, counting the extra bits, in this area of information theory and a little bit of coding theory. And we got to a reasonably good state with this, but the story needs finishing off. So I'd like to finish off the story and go back to our old example of San Francisco weather states. I'll try and make this completely understandable in a freestanding way, but if you do get a bit lost, go to the playlist and just catch up with the bits and pieces that you're not quite sure about. What we've done here is split them up into 4 good codes that are meaningful and 4 bad ones. We've been working for ages now with this very accurate model of San Francisco weather, that it's either foggy, sunny, cloudy or rainy, and you get about 25% of each of those states, so the probability is a quarter. It's a 2-bit code. Foggy, 0, 0. Sunny, 0, 1. Cloudy, 1, 0. Rainy, 1, 1. Fine. 4 states, 4 different bit patterns, 2 bits needed. What we, I think, then did right at the very end was this. What happens if you get a disturbance, electrical disturbance on the line, which either turns a 0 into a 1 or a 1 into a 0? Now, this is a good stage at which to say something which I've never actually emphasized before. We're assuming what Claude Shannon calls a symmetric channel. In other words, if a bit gets clobbered, it could be a 0 turning into a 1, or it could be a 1 turning into a 0, but if that happens, it's equally probable either way. In other words, there's nothing about a 1 bit that makes it different from a 0 bit in terms of its noise immunity. So it's a binary symmetric channel. We said, all right, let us add a 3rd bit to these 2-bit codes, and let us keep what's called the overall parity even. In other words, there must be an even number of 1s. So here we go, look, what could you add to 2 zeros as a 3rd bit on the right and still keep it even parity? Well, it's even parity already, so you can add a 0. If you send 3 bits, then so long as they arrive looking like one of these patterns, that's fine. But then you get things like, oh, well, suppose at Sacramento they get 0, 1, 0. That's not one of these 4. So what does 0, 1, 0 tell you? Well, it tells you that something went wrong, because it's not in the allowed set. But the problem is there's no end of ways that 0, 1, 0 could have arisen. So you can detect, but you can't correct. Then we got on to talking about how would Sacramento say back to San Francisco, I got it, I love it,